Welcome to the YouTube channel of Coding Club of RVCE. I'm Naman and we're discussing solutions to the CodeChef contest Starters 121. The question is Frequal. If you've not read the question, I'll explain it. So we have been given an integer n, that's it, and we have to construct an array of size n such that all the elements occurring in it occur the number of times the element has factors. For example, if we have an element 1, it should occur only a single time as it has only a single factor 1. If we have, say, 4, then it should occur 3 times because 4 has 3 factors 1, 2, and 4. If we have 5, then 5 has 2 factors 1 and 5. So it has to occur 2 times. Similarly, say 9. So 9 has 3 factors 1, 3, and 9. So it has to occur 3 times 1, 3, and 9. The other constraint is that we have defined a function over the array A, and the function is the number of distinct elements. So for this array, the number of distinct elements is 1, 4, 5. Sorry. Yeah, so the number of distinct elements is 1, 4, 5, and 9. So that's 4. So given the integer n, we have to construct this array such that the value of fa, that is the number of distinct elements, is maximum. That is the question. Let's move on to the approach. Since we have to maximize unique elements, I can say that we have to choose the elements which have the smallest number of factors. So when I choose the elements which have smallest number of factors, I can choose more and more elements so that the number of unique elements will be maximized. I can do this easily using prime numbers. So if you recall, each prime number has only 2 factors, 1 and the number itself. For any number greater than or equal to 2, it cannot have less than 2 factors, because if it has to have at least 2 factors to be a prime number, for any other composite number it has always more than 2 factors. Since we have identified the types of elements we have to put in the array, and since we have an unlimited supply of prime numbers, we can easily construct the array now. So for the n, if say n equals 7, that is an odd number, we have 7 places. For the first 6 places, I can put in the prime numbers. So the first prime numbers are 2, 3, and 5. We have 1 place remaining. For that, I can just put in 1 easily, as it has only 1 factor, so it has to occur 1 time. And for this final array, I have total of 4 distinct elements, and that is the maximum number that can be achieved. Hence, this is a valid array. Similarly, when n equals say 8, that is an even number, what I can do is just to use the prime numbers until the array is filled. So I can fill it 2, 3, 5, and 7. It can be shown that there is no other way so that we can achieve a higher number of unique elements. So for this element even, the number of highest distinct elements is 4. Since we have figured out the way to construct the arrays, let's move on to the code. So this is the code. I've taken in the number of test cases, but before moving on to each test case, I've calculated all the primes that can occur in the given range. So if you're aware with this concept of SIVO Eratosthenes, that's good. Otherwise, please look into it. It's a function that can give you the number of primes up until a given range. So I've created a vector of primes and I filled that using the SIVO Eratosthenes function. Now for each test case, I've taken in the number. If it's odd, then I print out 1 as the starting number, because then the number of remaining elements would be even, so I can fill them with prime numbers. Otherwise, we do not have to print 1, as the number of elements is already even, so we just fill them with prime numbers as it is. Now I've run a loop for n by 2 times, and for each iteration, I print the ith prime number 2 times. That's it. That would construct the required array. Let's try to run it. Yeah, it's working good. Yeah. So we've passed all the test cases. To discuss the time and space complexity for the solution, for the sieve of Eratosthenes function takes time complexity of n log n. And for each test case, I've run this loop, which takes time complexity of big of n. So the final time complexity of the whole code would be n log n plus the sum of all the number of elements that have been given in the input. That would fit in the required time constraints, and hence the solution works for the given constraints. That's it for this question. Thank you, guys.
Coding Club.